Introduction: Why biomechanics is crucial. Forensic biomechanics studies how physical forces interact with the human body during a traumatic event. In the case of a blow to the head, this discipline allows experts to reconstruct not only the intensity of the impact, but also the victim's position, the object's trajectory, and the overall dynamics of the action. Understanding these elements is essential to distinguish between an accidental impact, an intentional assault, or a fall. Biomechanics does not offer absolute certainties, but it provides a probabilistic framework grounded in physical laws and experimental data. The forces involved: energy, mass, and acceleration. Every blow to the head can be described through three fundamental variables: the object's mass, its velocity at impact, and the contact surface. The kinetic energy of the blow is defined by the formula E equal 12mv2, which shows that velocity influences the impact far more than mass. A light but fast object can produce greater damage than a heavy but slow one. The contact surface determines how force is distributed. The smaller it is, the higher the local pressure becomes. This is why an object with edges or rigid extremities tends to generate more pronounced injuries than a flat or rounded object. Types of impact: direct, indirect, rotational. A direct impact occurs when the object strikes the head perpendicularly, transferring energy in a concentrated manner. An indirect impact occurs when the head is rapidly accelerated or decelerated without direct contact with an object. Rotational impacts generate twisting forces on the skull and brain, often causing internal injuries even without fractures. Biomechanics distinguishes these categories because they produce different and recognizable injury patterns. The victim's position, a determining factor. The victim's posture at the moment of the blow decisively influences the distribution of forces. A standing person struck from above will experience a different impact compared to someone sitting or kneeling. Biomechanics evaluates the angle of incidence to determine whether the victim was upright, leaning forward, or in motion. The possibility of a subsequent fall is also analyzed, because a secondary impact against the ground can alter the injury pattern. Cranial injuries, what they reveal. Cranial fractures follow lines that depend on the direction of force and the stiffness of the bone. A linear fracture indicates a distributed impact, while a depressed fracture suggests a small, rigid object. Brain contusions may appear both at the impact site and on the opposite side, due to the coup-counter-coup mechanism. The presence of hematomas, abrasions, or scalp lacerations helps define the object's shape and the direction of the blow. Compatibility, between object and injuries. One of the main tasks of forensic biomechanics is assessing whether a specific object could have caused the observed injuries. This comparison is based on physical parameters, shape, size, stiffness, and the object's energetic potential. If the injuries show features incompatible with the proposed object, the reconstruction must be reconsidered. Biomechanics does not identify the object with certainty, but it can exclude implausible hypotheses. Movement dynamics, single or multiple blows. The distribution of injuries can indicate whether the blow was single or repeated. A single blow tends to produce a coherent pattern, while multiple blows generate overlapping injuries or injuries oriented in different directions. Biomechanics also analyzes whether some injuries may result from secondary impacts, such as a fall after the first blow. The difference between active blow and passive impact. An active blow implies that the assailant moves the object toward the victim. A passive impact occurs when the victim moves against a stationary object. Biomechanics distinguishes the two scenarios by analyzing force direction and injury distribution. The role of body kinematics. The human body is not a rigid system. During an impact, the head, neck, and torso move in complex ways. Body kinematics helps determine whether the victim was balanced, attempted to protect themselves, or was taken by surprise. Biomechanics as a reconstruction tool. Biomechanics does not replace judicial investigation, but it complements it with a scientific analysis of the forces involved. When applied correctly, it narrows down hypotheses and evaluates the consistency of the accounts provided. Conclusion. What the science of movement teaches us. The dynamics of a blow to the head result from a complex interaction between physics, anatomy, and human movement. Biomechanics does not offer absolute answers, but it provides a rigorous method for interpreting the signs left on the body. In a forensic investigation, this approach is one of the few tools capable of transforming a violent event into an analyzable and understandable sequence.